Let's explore how to use a multimeter to perform various measurements. Multimeters are versatile tools used by electricians and hobbyists alike to diagnose electrical problems and ensure proper function of devices. Let's get started. Although procedures may vary by model, the fundamentals of using a digital multimeter remain the same. Always prioritize safety and ensure your multimeter is rated for the measurements you need. Pay special attention to its CAT rating for different environments. Let's break down the fundamental parts of a multimeter. Display shows numerical readings like voltage, resistance, current, and frequency. Rotary switch selects the function and measurement range. Some meters are auto-ranging, others require manual range selection. Tip: if you're troubleshooting high-precision circuits or signals with large variations, you may prefer manual ranging to lock in a stable range. Terminals, typically 3, sometimes 4 on higher-end meters. Common, volts, amps, and milliamps. Buttons may include shift, min-max, range, auto hold, relative, and more. Test leads, probes that connect your meter to the circuit or device under test. Understanding these parts helps you measure accurately and safely. Let's look into a few common measurements. To measure resistance, set the rotary switch to the resistance ohms setting. Insert the black lead into the common jack and the red lead into the volts ohms jack. Touch the leads to the device under test. The reading will appear on the display. For a continuity test, set your meter to the continuity setting. Connect the black lead and the red lead. If the circuit is closed, the meter beeps. No beep indicates an open or broken circuit. When measuring AC voltage, set the meter to measure AC voltage. Connect the black lead first, then the red lead to your circuit. Read the voltage on the display. Remove the leads in reverse order, first the volts, then the common, when finished. For DC voltage, turn the rotary switch to the DC voltage setting. Connect the black lead to the negative side and the red lead to the positive side. Read the voltage on your display. Measuring current requires placing the meter in series with the circuit. Always check the fuse and meter's current rating first. Select the correct current range, amps or milliamps, and if necessary, move the red lead to the current port. Power down the circuit, break the circuit where you want to measure current, and place the multimeter in series. Double check all connections to ensure they're secure and safe, and then restore power to the circuit. Observe the reading on the display. If the current reading exceeds your range setting, switch off the power and move to a higher range and double check your setup before measuring again. Turn the circuit off before removing the meter, and always remove the red lead first, then the black lead. To measure capacitance, discharge the capacitor beforehand to avoid damaging the meter. Select the capacitance setting on the rotary switch. Connect the black lead first, then the red lead to the capacitor. The display will show capacitance in microfarads. When measuring frequency, set the meter to the frequency setting. Connect the black lead first, then the red lead. The display shows the frequency. For diodes, select the diode test setting. Attach the black lead to the cathode and the red lead to the anode for a forward bias reading. A good diode shows a forward voltage drop around 0.6 to 0.7 volts and should read OL when measured in reverse. Safety is incredibly important when dealing with electricity, so always keep these safety tips in mind. Know your meter's voltage limits. Check your meter's CAT rating for the environment you're working in. Ensure the meter's fuse is intact and appropriately rated for your current measurement. Disconnect and discharge circuits before testing resistance or continuity. Use electrically insulated gloves, insulated tools, and follow lockout-tagout procedures. Always connect the common lead first and remove it last. Follow the manufacturer's manual for specific instructions. Choosing the right meter depends on a few things. What functionality do you need? Will you be measuring voltage, current, resistance, frequency, diode test, etc.? Choose high accuracy and resolution for precise measurements. Look at build quality and safety ratings to match or exceed your environment. A clear display, intuitive layout, and helpful extras like a kickstand can make a huge difference in day-to-day use. Depending on your needs, you may need to look for a digital multimeter that has additional features like temperature measurement capabilities with a thermocouple probe, min-max functionality capturing for fluctuating signals, auto hold to capture stable readings, data logging for trend analysis, auto ranging versus manual ranging, non-contact voltage detection, Fluke Connect for wireless monitoring, relative mode to offset measured values, true RMS measurement for non-sinusoidal signals, analog bar graph display for signal analysis, and duty cycle or pulse width measurements for PWM circuits. Fuse replacement note: always replace a blown fuse with the same rating and type recommended by the manual. For instance, a 10 amp fuse for high current measurements or a 400 milliamp fuse for smaller current measurements. Professional or frequent users should consider periodic calibration to maintain accuracy. Keep your test leads and meter clean, check the battery, and replace fuses with the same rating specified by the manufacturer. A multimeter is a powerful tool that, when used correctly, can tackle a wide range of electrical measurement tasks. Always refer to your user manual for detailed fuse ratings, correct lead placement, and recommended calibration intervals. Thanks for watching this Fluke guide on how to use a multimeter. If you found this helpful, give us a thumbs up. Subscribe for more tutorials, and remember to stay safe out there.